Um, so a little background information for the 3D microscope. Something called an algae called Chlamydia. It is a small single-cell algae, approximately 10 micrometers in diameter, and it's what's called a model organism. So scientists study a lot just to understand certain things about algae. What's interesting about Chlamydia is that it has an ability called phototaxis, or phototaxing, which means that it will respond to and move towards light of certain wavelengths and frequencies. And this is based off of a rhodopsin-based eye that it uses to sense the light. The optimal range of sensitivity is between 350 and 650 nanometers. So that's the best light is like blues and greens. Okay. Now the second half of the background, this project is kind of a dual-parter. Right now, commercial microscopes operate essentially in 2 dimensions. The one that we would hope to build would be one that would be capable of understanding 3-dimensional movement. This will allow for total qualitative measurements of swimming movement. Where if you use a regular microscope, you put like a petri dish or something or a slide on the microscope and the light shines up and you just kind of look at it. What we're trying to do is be able to have, say, a tank of a liquid and put the bacteria in it and it'll swim around. And we can shine light from different areas, different angles, and be able to track the movement in a much more honest way than if you were forced to just sort of leave the chlamydia in a 2-dimensional containment area. And another important thing that's relevant as to why we need to do a 3-dimensional microscope is that chlamydia will grow in like a petri dish, but they require swimming around in a liquid media for around 24 hours on a light-dark cycle, 12 and 12, to grow the flagella around its side. The way our microscope would work would be we would utilize 2 dimensions. So it would be sort of like a, there would be a, sorry to explain. There would be a stand and there would be various devices set up along different areas on the stand, and we would be looking in 2 dimensions and tracking the 3rd dimension based off of light diffraction patterns. So that's what you see right here. The light is diffracting around the object. So we would be taking the quantitative the data, which would be x and y, or y and z, or x and z, or whatever, and then using as well as the light diffraction patterns to formulate the 3rd dimension. Okay, so the importance. Scientists use microscopes. It's important to use. It's also important to understand what we use as scientists, I feel like, and we feel like. I know, for instance, myself, I take microscopes for granted a lot. I don't particularly understand how they work as of right now, but this project would allow for us to create, a novel device, but also understand what we're using in the labs and stuff like that.
Jackson, can you go to go to the next slide?
Well, yeah.
Or at least to the bottom there?
Which
Yeah.
one? Which one?
The bottom of the next slide. Or
We all agree that microscopes are important.
we're looking for phototaxis and why I think.
Yeah.
Why
What
it's
your
worth studying.
plan is?
Oh, well, the thing is, our project is it's a chimeric project in that a big part of our pull is the physics aspect,
Yeah.
which is why what I'm saying is to just skip to the bottom part would be to shortchange the project as a whole. What we're trying to. Okay, all right, fine.
We just want to know what your plan is.
That's fine.
Okay, so what we'll be doing is we would be using the chlamydia essentially as first a test to make sure that our microscope works, because it would be moving around. We would probably put it in a certain spot.
So the construction of a 3D microscope is something that people have, there's nothing available. So
Right,
you're trying
yes.
to, this is some of the experimental part of this is really just to build something that's
Right.
3D microscope.
But the other thing is also phototaxing is an interesting process that's done by algae and things like that, and it's also very closely related to chemotaxis, which is very relevant among cells and it's understood in some respects, but still has stuff left to study.
So if the movement of this thing is what you're going to use to test if the microscope is working, what's novel about the movement of it?
It's a give and take. So the movement of the thing is what we're testing to make sure the microscope is working, and then once we know the microscope is working, we use it to understand more about the chlamydomona through different tests.
And what don't you know about the chlamydomona that you're gonna use?
I understand what you're saying, yeah, no. Well, first of all, Kevin and myself don't know anything about phototaxing. A lot of people don't know, a lot of average layman's people don't know anything about phototaxing as well. Phototaxing it parallels chemotaxing in a lot of respects, which is important because, so, they know the pathway is understood, but the actual actions taken by the cell or the algae in this case are not completely known right now.
Right.
So logistically we know, but effectively we don't.
So I guess, again, the thing I'm trying to figure out is what is it that you're trying to discover about phototaxis?
How it effectively works. So like on paper, we know how it works.
Right.
But in practice, we don't. And we would require a 3D microscope to actually view how in practice this works.
But what specific aspect of, I mean, like, you know.
So you're saying that we have a two-dimensional understanding of it, but we suspect there's more to it than that? So
Yes. We're trying to see what
in a three-dimensional view,
right,
how it might be different than our
that our two-dimensional
understanding of
understanding.
the two-dimensional stuff.
What, even in, can I stop?
No, it's alright. I got it. I'll take it.
Kirkhart? Good?
Do you have is there more?
I mean, we have the plans and procedures, but, I mean, what do you mean by more? I mean,
Well, is your presentation continuing?
yes, it does.
Okay. Okay.
So, first of all, from the microscope aspect, we would be ordering individual parts. Understanding the things behind each piece and how they work, why they work, where to put what thing where. This is sort of a loose schematic, is what I was trying to explain. So it wouldn't be your traditional microscope where you like look down it with the section on the bottom. I forget what terminology. It would be more like an extended, deconstructed telescope in a rough sort of sense, and we would essentially work it like that. So like I said, we would order the parts. We would understand the parts before we ordered them. Then we would order them. We would figure out, why is this working? Why do we need to be at this point? What is the max and min range it can be for optimal efficiency? Once we learn the physics behind that, we would then add the section of say like a camera, which would make the third dimension doable because you can't really do diffraction patterns with your head or your eyes. So we would use a camera. We would need a coherent light source. What a lot of people don't know, or a lot of people don't think about, is that most light bulbs, like the ones you see in the ceiling, are not coherent, and so what that means is all of the light frequencies, the light wavelengths are out of phase. They're kind of wompy and all over the place. We would need a light source that gives a precise and a direct.
Can you jump to your cost?
Sure. Okay. So everything right now except for the camera would be roughly $2,500, $25. I say except for the camera because they're like Sophia and Omni's project, they need a camera too. So we didn't factor in, the camera would range anywhere from like a couple hundred to a couple thousand essentially. But we don't know if the camera we would be buying would be for ourselves or if we would be able to share it and therefore the cost would be able to raise or lower depending on that factor. But everything else pretty much is set in stone at 25.
What's collecting the
This is like a startup type
Yeah.
of thing, and you guys have like shakers and incubators and pipettes and everything. This would be similar to that, right? As if you're building a biology lab from scratch and.
What's collecting your information? Like you have a sensor, right?
Oh, yeah.
Where's that information going?
Into a camera in the MATLAB. Does that answer your question?
No, I'm trying to figure out, do you need a computer on top of this stuff?
Yes.
Yes.
If you're gonna use MATLAB, you
Yes.
use
Tattoos
your.
are-
Yeah.
Also, we would also have to buy the MATLAB license.
That's not the one from last year. Is
How
it?
much is right?
If we were to
Student
get it for-
licenses are free.
Students on.
Free?
But there are other software that.
MATLAB is
You can use Python, that's open
Yeah,
source.
Python is free.
How long do you have kind of a projected time estimate for how long you spend building the scope? Like, do you think you would, finish this, do this year, and then like your people following you would do the phototaxis assays, or you think you're gonna?
Realistically, it's probably looking like we'll get anywhere from 3/4 to 100% of the microscope done over the majority of the year. Hopefully we'd be able to get it done and at least start the phototaxis section. But like I said, we're probably looking at us being the startups and passing it on to the people behind
If
us.
you don't get it done by ISP, would either of you take it on as your ISP project?
I'd be down for that,
Yeah.
otherwise I'd just be playing
I don't want
video.
to-
I guess what we'll think about this, right? But we the goal is the microscope, right? So
Yeah, that's the main goal.
if we're not getting the microscope at the end of this,
That was not really
No, we didn't.
And then the last slide, Dr. Samadani is our mentor. We meet 7:30 in the morning, 7:30 Monday morning. Kevin and I are both seniors. Because of that, we would probably hope for like 2 to 3 temps, preferably at least one junior who takes physics, enjoys it, is good at it, and plans on taking it next year as well. The other 2 or the other 1 would just be someone who is able to understand physics concepts, because I feel like physics is something you're either born able to understand or not.
Disagreeing.
That's nice.
Well,
It's a tough one to teach. It's a tough one to
you
teach.
just eliminated the need for a physics department. Good job.
Alright, I think that, anybody?
No, I'm good.
I'm good.
Thanks.
Um,